I'm Marcus Horton, and I will talk about the advances in stimulating the poor ovarian reserve patient. So in the next 10 minutes, I'd like to summarize this important issue for reproductive medicine nowadays. As you know, and this is data from our clinic in Buenos Aires, for the last 5 years, the average metaphase 2 retrieval rate has been 5 eggs. But if you look at the median, it's skewed to the left, and you can see that the most frequent numbers are 2 and 3 eggs. So this is something that we have in Latin America, and I know in most of the countries in the world have the same problem now, aging population, and we have our first IVF cycle. The average age is 38.9 now in our clinic. So as we know, if you look at the poor responder literature in the latest years, there has been an increase up to 2015, as you can see in this PubMed graph. But after that, it has plateaued, or has even decreased the number of publications of poor responders. And this is because the common strategies that we all have applied for the last 20 years, we know they really don't work. Even high-dose gonadotropins, microflare protocols, GnRH antagonists, LH supplementation, etc., they have been not useful for a poor responder because the bottom line is that you can't get eggs from an ovary that doesn't have enough eggs. If you look at the literature, and this paper by Barishata shows that the percentage of euploidy and aneuploidy rate is highly dependent on the women's age. And it's not related with the number of embryos generated. So it's always a percentage, and it's around 50%, the euploidy rate between 35 and 39 years of age. And there's even been calculations on the probability of at least obtaining one euploid blastocyst from a number of eggs. So we can calculate nowadays how many eggs we need to get a euploid blastocyst to optimize the pregnancy rates of our poor responder patients. So we've been shifting our practice from conventional approach to a more flexible approach, because we now have a lot of patients that will be benefited from a segmented cycle that we don't transfer in a fresh cycle. So low responders, advanced maternal age, but especially patients undergoing genetic testing. So we need to increase the number of oocytes to increase the probability of a euploid blastocyst and decrease the time to pregnancy and the dropout rate, because we know these patients get really frustrated with only one retrieval, and the dropout rate has been reported as high as 30, 40, and even 50%. So I will introduce you to multiple oocyte retrieval protocols. These nowadays are called duostim, bistim, the different protocols. I will show a few of them. And it's based on the physiological phenomena that women, as well as other in other species, we found, especially in the bovine, that we can stimulate at any time of the cycle, and you can even have 1, 2, or 3 waves of follicular genesis during a single cycle. So this has been, for the last years, proved to be efficient. First case reports doing random stimulation, starting on the follicular phase or starting in the luteal phase, or doing dual stimulations, as is shown here in the Shanghai protocol that was very famous at the time. And then there was safety papers published on the safety of stimulating either on the follicular or the luteal or both phases. So now there's already a meta-analysis, a systematic review that has recently stated that those non-conventional approaches, as random start or dual-stim cycles, could offer more flexibility in a reduced time frame. And that's the basis of this, flexibility and timing. So these are the first prospective randomized trials. This is Filippo Baldi's paper, very famous, with 2 stimulations, one in the follicular and another one in the luteal phase, both using antagonists and gonadotropins with a 4-day stop between both, and he showed that's safe and could increase cumulative pregnancy rates, as you see here. New papers coming out from France. They call this a BISTIM study, and they randomized either to receive a first stimulation followed by an embryo transfer, so 2 conventional cycles here, versus a first stimulation with vitrification and a second stimulation, and after those, a frozen embryo transfer, and they didn't show any difference in terms of pregnancy rates, clinical pregnancy rates, and live birth rates. And this has sparked discussion in the literature. This is another paper from a group in Europe that have, and here you have the comparisons of Ubaldi's protocol, this French protocols where they use 2 different stimulations, also in follicular and luteal phase, in this case, triggering with HCG. Philippe Ubaldi's group was triggering with an agonist. And this paper by Baudry, the French group that has proposed a continuous use of gonadotropins, they don't stop between one and the second, the first and the second stimulation cycle. And they found no differences in the number of M2 eggs in the good quality embryos, and the numbers really are low and are insufficient to compare pregnancy rates. And this last recent paper by the group in Nikos Polisos group in Europe too, and 107 patients randomized to a duostim start, but in this case, and it's a very attractive protocol where they start in luteal phase, they continue in the follicular phase for the second cycle, and this allows them to transfer in a fresh cycle. So 2 stimulations, one after the other one, but starting on the luteal phase and transfer. And this group achieved a higher number of good quality blastocysts, but it didn't affect the results with French transfer. But these results are limited to 1 cycle, so there's no cumulative pregnancy calculation. So this discussion in the literature now is if duostim is a better protocol than single stimulation, but the bottom line is this is not a specific treatment. Duostim is a strategy. You can do double stimulation, even triple stimulations. And if you compare it to single stimulation, you may not find a big difference in favor, but the logistics and the patient dropout rate is going down when you do a double stimulation. I will show you some of our experience in Pregna. We've done more than 1,300 cycles now, and even a few triple stimulations, as you can see. And now it comprises around 20% of our cycles. And with the dropout rate has gone down, it's 13% now, and probably because of no oocyte retrievals or poor results in the first, and that the patient wasn't willing for a second stimulation, and in some cases for an unexpected good response in stimulation 1. Another item that I will talk upon is the intravariant PRP, the platelet-rich plasma. This has been in the media for some time, and even in reviews and meta-analysis. This is a paper from 2021 talking about the standardization, the poor standardization of the papers. There is even a meta-analysis with more than 1,200 patients, but with very poor quality papers included. And now this year, there's 2 randomized, well-designed papers from 2 important groups, one in Europe and in the States, and they found no difference. They did 3 cycles in a row using a PRP in the first cycle. They didn't find difference between groups, but there was an incremental number of eggs in both groups with the second and the third stimulation. So, and that is something that we've seen also in the dual stimulation and duostim groups in general. So what about new developments? And this is really exciting. I was captured by this posting in Nat Geo on Instagram. It's not a scientific journal, but it pointed out to the fact that nowadays there is some research on new molecules that could increase the ovarian reserve, that could increase even the poor ovarian patients' response. And there are some AMH analogs under development, and especially a new molecule that is pointed to the fact that the previous paradigm of aging is including genomic factors, stem cell exhaustion, and cellular senescence, but also now the new paradigm includes chronic inflammation as a phenomenon. And this includes the ovarian environment, where some researchers have found that rapamycin, a molecule that has been shown to inhibit the mTOR protein pathway, very involved in chronic inflammation. Rapamycin has shown to improve quality and developmental competence in vitro matured oocytes in mice and humans. It has been shown also to prevent cyclophosphamide-induced ovarian follicular loss, and now a recent paper by Romero's group in Israel has shown that the dual suppression of follicle activation pathways with an AMH analog plus rapamycin completely prevented the cyclophosphamide-induced loss of ovarian reserve. So this is very exciting news from a group in the States that are starting this protocol. Is a prospective study now enrolling patients, more than 1,000 women, trying to use rapamycin in ovarian aging. So this is for 12 weeks, rapamycin versus placebo, and probably in the near future we'll have news about this. So with this, I'd like to finish my presentation and invite you all to next year's IFFS World Congress in Tokyo in April. And also follow us, please, if you scan this, and follow us on social media. So I'd like to finish my presentation now and thanking you very much for your attention. Thank you very much.